Hello class, this is the last example on series problems. Fair warning, this is a rather difficult problem, so I hope you give it a go before we continue. So here we go. I've already written up the two expressions that we will be using. It's just the sum of an arithmetic series and the term for an arithmetic series. Let's change what it says here. The sum of the first 16 terms is 96, and it's an arithmetic series because we're being told that. So the first 16 terms, so 16 over 2 of 2a plus d, 16 take away 1 is 15. It's equal to 96. Simplifying this, 16 divided by 2 is 8. So it's 8 over 2a plus 15d is equal to 96. Simplifying this further, I'm going to divide both sides by 8. Gives us 2a plus 15d equals 12. This is going to be one expression we're going to be using. The next bit of information we have to utilize is here. T2 plus T4 equals 16. Well, T2 is going to be A plus, utilizing this one here, A plus D. 2 minus 1 is just 1. Well, we get A plus D. T4 is equal to A plus D. N minus 1, so 4 take away 1 is 3, so we get 3d. So just move this across. We get these two expressions. Utilizing what it says here, T2 plus T4 equals 16. So adding these two together, A plus D plus A plus 3d, that's T2 plus T4 is equal to 16. Bringing these two together, a plus a is 2a, d plus d is 4d, equal to 16. Here's our second expression, and now we can see two different expressions that we need to simultaneously solve. Taking the first one, 2a plus 15d equals 12. Below it, we'll place 2a plus 4d equals 16. We're going to minus these two to eliminate one of the terms. 2a take away 2a, that cancels. 15 take away 4 is 11d. 12 take away 16 is negative 4. Dividing both sides by 11, we get negative 4 over 11, and that is our common difference. Substituting this back into either one of the expressions, I'll just pick this one because why not? We get 2a minus, plus 4 times d, which is now negative 4 over 11, should equal 16. Calculating this, 4 times negative 4 over 11, we get 2a minus 16 on 11 equals 16. Moving this fraction to the other side, so 16 plus 16 on 11, we get 192 on 11, which means a, if we divide this by 2, gives us 96 over 11. And that's the other expression that we need. So we have the first term and common difference. Let's write this way up here as we continue this question. So we have a equals 96 over 11 and d equals negative 4 over 11. So now we're finding an expression, or n, such that s of n is equal to s of 16. So this is implying that we have a different sum equaling s of 16. Okay, so s of 16, we saw was equal to 96. So let's find let's find a expression for this sum that equals to 96. We've actually already done this here, but this time instead of the 16th term, we're going to leave it as n. So s of n is equal to n over 2. Substituting our numbers in now, so 2 times a, so 2 times 96 over 11, minus d, so minus 4 over 11, n minus 1. All of this should be equal to 96. Okay, so multiplying both sides by 2, we get n. So I want to eliminate this guy. So n outside of, let's evaluate this. 2 times 96 over 11. We get 192 over 11 minus, I'm going to expand this bracket here. 4 times n over 11 is going to be 4n over 11. Negative 4 over 11 times negative 1 is plus 4 over 11 equals, because we've multiplied by 2, 96 times 2 is going to be 192. Collecting like terms, these two are like terms. So 192 over 11 plus 4 over 11, we get n outside of 196 over 11 minus 4n over 11 equals the right hand side, which was 192. Expanding this, n, we get 196n over 11 minus 4n squared over 11 equals 192. I'm going to multiply everything by 11 to get rid of these fractions. So we get 196n minus 4n squared equals 192 times 11 is 2112. This is now going to become a quadratic. I'm going to eliminate that 4, so I'm going to divide everything by 4. So we're left with negative n squared. 212 divide 4 and 196 divide 4. So this 196n becomes 49n, and 212 becomes 528. Rearranging this, we'll move n squared to this side. Actually, let's move everything to this side. It becomes positive n squared negative 49n plus, because the 528 is on the same side, plus 528 is all equal to 0. We now need to solve this. We could try and factorize this, but ain't nobody got time for that. So n, I'm going to use the quadratic formula, negative b, so negative 49 is positive 49 plus minus b squared minus 4ac. So 49 squared minus 4 times a, which is 1, times 5, 28. We'll take the square root of all of that, divided by 2. Let's evaluate things nice and slowly here. Let's do the 49 squared minus, so 49 squared minus 4 times 5, 28. Let's hope it's a positive. It is. So 49 plus 289, that's going to be in the square root, divided by 2. Let's take the square root of 289. So we're left with 49 plus minus 17 all over 2. Taking the positive, actually let's take the negative first. So let's go in order here. So negative 2, and the next one we'll take the positive. 49 plus 17 all over 2. 49 take away 17 over 2, that's 1. 49 plus 17 on 2, and that's the other one. So the two terms that we get are 16 and 33. So answering our question, find n such that s of n equals s of 16. Well, we already found that right from the beginning, we knew that the sum of the first 16 terms was 96, but it seems that the sum of the first 33 terms is also equal to 96. So we can say here that s of 16 is 96, and s of 33 is also equal to 96. So this is actually enough, so we can say s of 33 is equal to s of 16, which answers our question. So, hope you found that question rather interesting. I know it's rather difficult, but I hope that gave you an insight into how we might go about answering these questions. Hope to see you in the next video. Best of luck.